Hello, and welcome by today's tutorial on spline networks. In order to create an AGV simulation, several components are required to design a motion web, which defines the routing network for motion web actors. These components involve dynamic splines, queues, the motion web actors, and the hierarchy. Together they form the motion web. This tutorial will focus on the dynamic splines and the queues. Dynamic splines define the movement from one control point to the next. This movement is caused by a motion tensor assigned to the splines. Basically, when a motion web actor arrives upon control point, let's call it point 1, the motion tensor will set a velocity and direction toward control point 2. If the actor arrives from the other side at point 2, the velocity will be negative and the direction will be set toward point 1. Today we're going to focus on creating a network of splines. The scene we are using is a basic scene, using a desk controller, an actor manager, one actor, and a motion map, which is currently empty. The first thing we're going to do is create an empty object within the motion map, which we're going to call Route 1. Within Route 1, we're going to assign a component called spline, which makes the object a dynamic spline. Within the inspector, we can see the spline length, which is currently 1 meter. As explained, each spline consists of two control points. One, which is located at the coordinate 0, 0, 0, and control point 2, which is located at the position 1, 0, 0. To increase the length of the spline, we can adjust the coordinate of control point 2. We can do this either by hand, by dragging it over the screen, or we can adjust it in the coordinate field to be more precisely. As you can see, we now translated it to the coordinate 3, 0, 0, and therefore increase the spline length to 3 meters. The next thing we're going to do is create another empty object within the motion map, which we're going to call Route 2. Again, apply the spline, now creating a second spline. This time I'm going to put control point 1 on top of control point 2 of Route 1, which was at coordinate 3, 0, 0. Control point 2 is now going beneath control point 1 by applying 3, 0, minus 3. We now created our second spline. Now create another empty object, which we're going to call Route 3. This time we're going to put it on top of Route 1 by adjusting the coordinates of point 2. Let's put it to 3 of 0, 0, 3. As you can see, we now created the 3 loose splines, but we didn't create a network yet, because in order to connect them, we're going to need junction queues. Now we're going to create another empty object within Route 1, which we're going to use as a queue folder. Then assign an object, which we're going to call junction 13, and add the component called junction queue. A queue is always part of a spline and can therefore be located somewhere between 0 and 100% of the spline length. As we can see, Route 1 is the owner of this junction queue, which is currently located at the beginning, so at 0%. Furthermore, every queue is assigned to a specific instructor, which can use the queue's data for interactions with the actor. A junction queue is always assigned to the actor manager, since it's the parent of the motion map, which we can see. At last, each queue has a certain thickness, which is used to establish its location on the spline and detect any actor passing through. For junction queue, it's fine to leave this thickness at 0. Now let us connect Route 1 and Route 3. Since Route 1 is the owner of the junction queue, it will be used as junction point A. Therefore, Route 3 will be assigned to junction point B. We want the junction queue and the control point we're going to use to be aligned at the same location. As we can see, control point 2 is at the top side and control point 1 is down at the same location as junction point 13. Therefore, just drag control point 1 in there and clamping, which physically connects the two splines together. If junction Q13 would not be at the same location as point 1 of Route 3, point 1 will be translated toward the junction queue when enabling clamping, which might mess up your network. But as we can see, Route 1 and 2 are both directed clockwise, while Route 3 is directed counterclockwise. In order to fix this, we're gonna enable the clamping, and we're gonna use the spline and then invert the spline. As we can see, point 1 is now at the top and point 2 is down, which makes all 3 splines directed in the same direction. Now go back to junction 1, 3 and drag now control point 2 in there, since we now have the other control point, which is located over here. And then clamping, and we now have a network of 2 splines. We're going to repeat the same process for junction 1, 2. Again, create an empty object, which we're going to call junction 1, 2, and assign the junction Q component. This time we want to be positioned at 100%, so we imply 1. Assign it to the actor manager, and this time we're going to use control point 1 of route 2. And clamping, and if everything has been performed correctly, we now have a network of 3 connected splines. Aside from connecting all the ends of the routes together, it's also possible to create another spline and connect it halfway through. Let me show you by creating another route called route 4. Apply the D-spline and place the coordinates at 3, 0, minus 1.5 and the second one at 5 and minus 1.5. Now we're going to create another junction queue, assign it within route 2. Let's say folders with queues. And we create junction 2, 4. We're going to take the junction queue and we're going to say queue retain will position. We're going to assign the actor manager, and we're going to now use a tool within the utilities called the alignment tool, where we're going to align the junction queue towards the correct control point. Now apply the alignment, and as we can see, the junction queue 2,4 is now located at the exact same position control point 1, making sure that we don't mess up the network when enabling and clamping. Now drag in control point 1 over here and act, and we now have a network of 4 different splines. Aside from junction queues, we also have desk queues. As mentioned before, queues always have a certain thickness and are always child of a specific spline. A desk queue can therefore detect whenever an actor enters or leaves its area or crosses the center point. Desk queues are specifically used to detect actor behavior and signal the assigned instructor. This can, for example, be used to assign locations within the actor manager, whereas the manager knows where the queues are located and create a route for the actors, and the queues can detect and signal the manager whenever an actor arrives. Well, let us start by creating a queue called queue start. We're going to assign it within route 3. Again, we create a folder called queues, and we're going to create a desk queue, which we're going to call queue start, and assign a desk queue. We want it to be located at the top, so at 0%. We're going to assign the AGV manager or the actor manager, and we're going to give the thickness of 0.25. Now we're going to make 2 queues for the finish, one at route 2 and one at route 4. So again, we create the queues for easy hierarchy, and then we're going to do queue finish. This is at route 4, and we're going to assign it to the actor manager, and we want it to be located at the end. Again, give the thickness of 0.25. As we can see, it established itself on this location of the spline. We're going to do it again for the queues in route 2, queue finish 2, add a desk queue, assign to the actor manager. This time we also want it to be at the totally of the end. And we give the thickness of 0.25. So the next thing we're going to do is assign locations within the actor manager. We're going to put it on size 3 and assign a start and both of the finish locations. After all the queues are assigned, we can do re-index Motion Web from selection, which automatically creates the routes between all the nodes and uses them within the actor manager. We now have set up a network of splines available for our actor. If we press play, I can show you in play mode how it works. As you can see, an actor always starts on a cue point, and we have 3 of the locations we can send them to. We can send them to location 1, which moves the actor to finish 2, which will be over here. Afterwards, we'll send them to location 4, which is over here. And we can also send it back to the start, as we can see. So in conclusion, we have created a network of splines with different cues, dash cue for the assignation of locations, and junction cues for the connection. And we have an actor which can move over the spline network to reach locations. Thank you very much, and until next tutorial.